Aloha kids, this is the 5 basic problems we have on our fundamental practice sheet. This is A actually up there, forgot to put it on there. First problem is a calculator. This is just looking up stuff on the calculator. Okay, tangent of 22. You could do sine, cosine, or tangent here. Remember, that's sine, not sin, cosine, tangent. Use the right names. Don't sound like you don't know what you're doing by using the wrong names. So tangent to 22, I'm just putting that in the calculator. Now I got the Desmos calculator up here, DESMOS. Tangent 22, one nice thing about this, it looks exactly like you're writing there. You do want that in parentheses. I should have showed that this is in degrees mode. If you put it in a different mode, it'll get a different answer. And you can see there's our answer. Now notice, we are rounding here to 10,000ths. That's 1, 2, 3, 4 decimals. Okay, we actually look to the 5th one. So we've got 4040. That's the 10,000ths. I look at the 2, that says round down. So it just goes in as 0.4040. And that's my answer. So I should say that's about like that. I should probably write it like this. There should be an equals in there. And again, so this would be tenths, hundredths, thousandths, and our 10,000ths. There should be THs there, I guess. Okay, so just put it in your calculator, sine, cosine, and tangent. Notice if you change this to radians, you get a whole different number in there. Tangent of 22 equals that. Looks different. You want to make sure you're using the degrees. Okay, sine of A, this is like our point. And again, there's nothing right there on it. It's just our point for the IXL. They do this slightly differently than ours. I'll show it to you. So first off, don't forget your SOHCAHTOA up here. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. SOHCAHTOA. Have that written down, have it memorized, always have it handy, whether it's on paper or in your head. So I'm looking at angle A, that's this angle down here. And I got sine is opposite over hypotenuse. So I take a look over here. Well, this is my opposite leg because it's across from the angle. This is my hypotenuse because it's across from the right angle. So I like to mark those down so I know what I have. And when we write this out, this is going to equal opposite, again, opposite over hypotenuse. So that's 16 over 34. But if you put this into IXL, you will actually get it wrong because this can be reduced. These are both even. You can reduce by 2. So IXL wants to see 8 over 17. Here they want 10,000, so I got to go to my calculator over here. And it's just 8 divided by 17. And again, 0.4705. There's my 5th decimal after the 10,000s. That says round up. So that's going to be about 0.4706. And I did have the abouts there too. And so that, you know, this is the IXL, what the IXL wants. This is what this assignment wanted there. Pay attention to what the directions ask you for. Okay, so again, that's the R point. That's the first one in the R's to do that. I recommend doing that one first. Find the missing side. This is like R10 in IXL. I can't write. Your IXL geometry. Now, I forgot to mention earlier, notice, sine, cosine, tangent always come with an angle measure or an angle name. You always got to have something with it. It's connected to that. It's part of the same thing. It's just one number. On number 2, I'm thinking, when I was thinking sine A, I was just using that rule. Sine of some angle is opposite over hypotenuse, opposite leg over hypotenuse. I just put those numbers in. I'm going to use the same principle here, but it's going to work slightly different. So I got my 18-degree angle down here. Relative to that 18-degree angle, that's my opposite leg. This is my adjacent leg, because it's adjacent to our angle down here that we're looking at. Notice I know it's not the hypotenuse because the hypotenuse is always across from the right angle. I recognize that one in every triangle. So that's my adjacent leg there. So again, I'm using that basic concept, the SOHCAHTOA, and I'm noticing, okay, here I got opposite and adjacent. Opposite and adjacent are tangent up here. And so I'm going to use tangent. So this time we know tangent of some angle theta equals my opposite leg over my adjacent leg. Well, just put in the information from the problem, just like you did up here, not that different with sine. So it's going to be tangent of 18 degrees equals 12 over x. Now, don't forget that little proportion trick I showed you where you can switch these numbers on the diagonals. So we're going to switch those. So we're going to end up with x equals 12 over tangent of 18 degrees. Now, again, I just put that into my calculator at this point. Clear all. So I got 12 divided by the tangent. Ooh, notice how that division just put it into a fraction. 18 degrees, close them parentheses. Again, it's asking us to round to the nearest tenth. 0.9 is tenths, because again, if you think 10, you got 1 0 there, so that's 1 decimal. So that's 9. I'm going to look at the 3, that says round down. So x is going to be, whoops, about 36.9 units, whatever those would happen to be for this problem. Now, solving these, just don't forget, not everyone has x on the bottom, not everyone has x on the top. If I had cosine of 59 equals x over 3, I would multiply each side by 3 to solve that. The 3's would cancel out, and then there would be my answer. 3 times cosine of 59, I just have to multiply it out. Number 4 is mostly a calculator problem again. So we have these things over here. Let's get these. ABC, main function. Sine to the negative 1, cosine to the negative 1, tangent to the negative 1. Okay, those are called inverse. Sine inverse, cosine inverse, tangent inverse. So that negative 1 power means inverse. Okay. And there's like, what do you call that? Square and square root, they basically undo each other. So I'm doing the sine inverse to this side and the sine inverse to this side. These cancel out. And it's not so much x, I'm going to say the measure of angle x is equal to sine inverse 0.9455. My computer's slowing down. Now, that's just calculator work, basically. So I come over here, I clear off what I got, and cosine and tangent work the same way as this. Sine inverse, again, that negative 1 in the power, that's what says inverse. And then what do I have? I got to go back to my main one here. Now you can put the 0 in, you don't have to, that's just 0.9, whoops, undo, undo. I want that -1. I need to be there. 0.9455. And we're going to the nearest degree. Nearest degree means nearest unit. That's going to be that one right there. That's my degree. So I look at the one to the right of it to round up. 0.9 says round up. So the measure of angle X is going to be approximately 71 degrees. Now we really use that same skill on the next one. So this is again combining that in our SOHCAHTOA. And I look at this problem. I got, whoops, draw, undo, highlight. I got, there's my angle. Related to that angle, this is my adjacent leg. This is my hypotenuse. I look at that adjacent and hypotenuse. That's right there. That's part of cosine. So again, I'm using that basic idea. Cosine of some angle theta equals, it's not writing well, adjacent over hypotenuse. So it's going to be cosine of that question mark equals 31 over 48. You don't have to write this in all the time. So I'm using that cosine inverse. So the measure of my question mark angle is going to be cosine inverse of 31 over 48. Now you don't have to divide that out and put it into a decimal. You can just put it into your problem. So I'm going to go, I got to go function here, cosine inverse, back to the main one. 31 divided by 48. I'm going to close that. Whoops. There we are. Got that in there. And we can see that goes to 49.77. I'm going to the nearest degree again over here. I don't know why I didn't select that. Nearest degree. Because it's a picture. And again, that 0.7, that first 7 says round up. So this is going to be the measure of angle question mark is about 50 degrees. And that's it. This is our, I should have mentioned this earlier, this is IXLR11. Okay? That's it, kiddos. You have a good one. Hope this helps some. You have a good day, good morning, good afternoon, good evening. It's evening for me, so I will catch you all later.